Imagine gazing up at the night sky, eyes fixed on that small, reddish dot that has captured the human imagination for centuries. Mars, the mysterious neighbor that has long fueled our dreams of discovering life beyond Earth. For decades, scientists have asked the same tantalizing question: could Mars have ever harbored life? Now we stand on the brink of answers that could redefine our understanding of the universe. Enter Perseverance, NASA's most advanced rover, designed not just to explore Mars, but to unlock its deepest secrets. Equipped with cutting-edge technology, Perseverance is more than a machine. It's a robotic pioneer on a quest that could reveal whether Mars was once home to microbial life. As it traverses the Martian surface, Perseverance isn't just gathering rocks and dust. It's collecting clues, pieces of a cosmic puzzle that, when assembled, might point to one of the greatest discoveries of all time. This mission isn't just about scientific curiosity. It's about answering fundamental questions that have echoed through the ages. What if we're not alone? What if life once thrived on this distant world? As Perseverance digs deeper into the Martian terrain, the possibility of uncovering those answers feels closer than ever before. The rover's journey is not just a step forward in space exploration. It's a bold leap into the unknown, where each discovery brings us closer to understanding our place in the cosmos. And now, with each passing day on Mars, Perseverance is turning speculation into tangible evidence. The rover has already made remarkable discoveries, and at the heart of these is a rock sample named Roid Bill. This seemingly unremarkable piece of Mars is anything but ordinary. Rich in hydrated silica, a mineral known on Earth to preserve ancient life, Roid Bill could be the key to unlocking Mars' past. Imagine within its layers the possibility of microbial fingerprints, frozen in time, waiting to tell the story of a world that may have once teemed with life. But Roid Bill isn't alone. Other samples with names as intriguing as their origins, Pelican Point and Comet Gazer, suggest a landscape shaped by the flow of water. Long before Mars became the cold desert we see today, water, the cradle of life as we know it, might have once coursed through these rocks, carrying with it the building blocks of life. The evidence is mounting, the textures, the chemical compositions, all pointing to a Mars that was once warm, wet, and potentially alive. As Perseverance carefully stows away these precious samples, the anticipation builds. Each rock, each grain of Martian soil could hold the secrets of life's ancient past. What stories will they tell when they finally return to Earth? What will we learn about Mars? And more importantly, about the origins of life itself. The discoveries so far are just the beginning, hinting at a history that's more complex and more fascinating than we ever imagined. But the secrets of Mars aren't just buried in its rocks. They also linger in its thin, dusty atmosphere. Perseverance, ever the diligent explorer, has captured something that could be just as groundbreaking as the ancient minerals: an atmospheric sample. This isn't just any sample. It's a snapshot of the very air that swirls around the Martian surface, a mixture that could hold the key to understanding whether Mars still harbors traces of life today. Among the gases in this atmosphere, one stands out: methane. On Earth, methane is often produced by living organisms, and its presence on Mars has sparked intense curiosity. Could it be a sign that something is still alive on this distant world? Or does it hint at ancient processes long since dormant that might have once supported life? As scientists on Earth eagerly await the detailed analysis of this Martian air, the possibilities seem endless. If Perseverance's instruments can detect even the faintest whiff of biological methane, it could point to the existence of microbes living beneath the surface, hidden away from the harsh conditions above. Or perhaps the methane tells the story of Mars' past, a time when the planet was warmer and more hospitable, a time when life might have flourished. This sample is more than just a collection of gases. It's a potential whisper from Mars itself, a message carried across millions of miles, waiting to be decoded. And with each piece of data, each new discovery, the excitement builds. What else might Perseverance uncover in this alien atmosphere? Could we be on the verge of one of the most profound discoveries in human history? The answer could be floating right there in the Martian winds. And yet, as revealing as the atmosphere might be, there's something even more intriguing lying just beneath the surface of Mars: the regolito, a fine layer of dust and broken rock that blankets the planet. At first glance, it might seem like nothing more than the byproduct of eons of wind erosion and meteor impacts. But the truth is far more complex. This regolito is a mosaic of Mars's geological history, potentially hiding within it the remnants of ancient environments from across the planet. Perseverance has meticulously gathered samples of this dust, knowing that each particle could hold clues from regions far beyond the rover's current location. Imagine embedded within this dust traces of minerals and compounds from volcanic eruptions, meteorite impacts, or even from underground aquifers that might have once bubbled to the surface. The regolito is like a time capsule, containing fragments from various chapters of Mars's history, each with its own story to tell. But what makes these samples truly exciting is the possibility that they might contain more than just inert materials. Scientists speculate that within this Martian dust, there could be organic molecules, complex carbon-based compounds that are the building blocks of life. If found, they would add yet another piece to the puzzle, suggesting that the conditions for life may have existed on Mars for much longer than we ever thought. These samples of regolito aren't just a dusty collection. They're a key to understanding the broader picture of Mars. They provide a unique opportunity to look beyond the rover's immediate surroundings and piece together the planet's vast and varied geological history. What will these tiny grains reveal when they're finally analyzed? Could they point to regions of Mars that were once habitable, or even to pockets of life still clinging on in hidden crevices? As Perseverance continues its mission, the answers seem tantalizingly close, waiting to be uncovered in the fine Martian dust. Yet, as Perseverance diligently collects these precious samples, there's a growing realization that the most critical chapter of this story is still to come: the journey back to Earth. For all the groundbreaking discoveries made on Mars, the true potential of these samples can only be unlocked when they are brought home for analysis with the full power of Earth's laboratories. But this final step is fraught fraught with challenges, both technical and political. NASA has bold plans to retrieve these samples, but the mission is complex, requiring a carefully orchestrated series of launches, landings, and rendezvous in deep space. There's no room for error. The stakes are incredibly high, not just for the science, but for what it represents: humanity's first attempt to bring back material from another planet with the hope of finding life. Complicating matters further is the global race for space supremacy. China, too, has its sights set on Mars, with plans to launch its own sample return mission. The pressure is mounting, and the competition is fierce. For NASA, success isn't just about scientific achievement. It's about maintaining leadership in the exploration of the final frontier. The world is watching, and every step counts. As the clock ticks down to the launch of these retrieval missions, the excitement and tension build. What will these samples reveal once they're finally back on Earth? Could they contain definitive proof that life once existed, or still exists, on Mars? Or will they raise new questions, pushing the boundaries of our understanding even further? In the end, Perseverance's mission isn't just about exploring another planet. It's about exploring the very nature of life itself. As these samples await their return to Earth, they carry with them the hopes and dreams of all humanity, poised to answer one of the most profound questions we've ever asked: are we alone in the universe? And as we prepare for what comes next, the anticipation is electric, for we stand on the brink of a discovery that could change everything.